So here's part B of number 5 from the 2012 A, B, and BC exams. And in part B, they want us to find the second derivative of b with respect to t. It's allowed to be in terms of b, and then we want to use it to explain why the graph of b cannot resemble this graph. So we have the first derivative right here. If we want to find the second derivative, the easiest way to go about this is to take both sides of this equation and do the derivative of each side with respect to t. So we'll do the derivative of that side of the equation with respect to t, and then we'll also do the derivative of this side of the equation with respect to t. Now one thing that you can do, and I am going to kind of backtrack here and do it at this point, this equation right now is technically a product. What I'm going to do is I'm going to distribute my 1/5 into the parentheses just so that I don't have that product to deal with when I'm taking my derivative. So I'm going to distribute 1/5 to 100, and that's going to become a 20. And I'm going to distribute 1/5 to negative b, and that's going to become negative 1/5 b. And so the derivative on the left is pretty easy. The derivative on the left is just going to be our second derivative, so the second derivative of b with respect to t in Leibniz notation. And then over here, the derivative of 20 with respect to t is 0. And then the minus 1/5 is a constant, so I'm going to copy that into my derivative. And then the derivative is not being done on this side with respect to the variable b. The derivative is being done with respect to t. So the derivative of b with respect to t is db dt. Now, the 0 doesn't really need to be shown. I'm going to get rid of that at this point. This is not what they asked us to do, though, because it says find the second derivative in terms of b. Right now, our second derivative is in terms of db dt. So what we're going to have to do is we're going to have to figure out how to get b in place of this. Well, we know what db dt equals. It equals this. We can substitute this in place of the db dt in our second derivative. So our second derivative is going to be equal to negative 1/5 times db dt, which equals 1/5, times 100 minus b. Explain why the graph of b cannot resemble this following graph, and use this to explain that. Well, if you think about what the second derivative tells you about the graph of the original function, it tells you about the concavity of it. Let's look at this a little bit closer. Let's actually simplify the second derivative a little bit. Actually, I guess we can leave it in this form. So if we leave the second derivative in this form, this first piece of the product here is obviously negative. That'd be negative 1/25. So I'm going to rewrite this as negative 1/25 times 100 minus b. Now, think about what this represents, and think about what this represents. In the problem statement, which we discussed a little bit in part A, the problem statement said that this rate of change, I could get back up to where it says it, the problem statement said that the baby bird gains weight at a rate proportional to the difference between its adult weight and its current weight. If b is its current weight, 100 has to be its adult weight. So thinking about this quantity with that in mind, this is the adult weight of the bird. This is the current weight of the bird. The current weight is never going to exceed its weight at maturity, full maturity. So this set of parentheses right here is always going to be positive and eventually 0 once the bird's an adult. So this is positive if we have negative 1/25 times a quantity that's always going to be positive and eventually a very small positive value until it's finally 0. The product of a negative and a positive is always going to be less than 0. So what this work implies is that the second derivative for any value of b is always going to be less than 0. What's that tell you about the graph? Well, what that implies about the graph is that the graph of b is always going to have to be concave, well, second derivative negative, or concave down. Check out the proposed graph that they have. they have a graph that's obviously concave up at the beginning. Now eventually somewhere in here we have an inflection point and then we're concave down, but since we're concave up initially, there's absolutely no way, given what we just discovered about this second derivative, there's no way that this could be a graph of B. Now I'm not going to write all that out on the AP exam. You'd obviously have to do that to receive full credit for the explanation part of part B.